Cool. Hi, everybody. My name is Kit, and I think on the wiki page, the title of the talk is a little bit different. So I'm not going to talk too much about Kubernetes in general, but rather it's a really specific area which is related to the Ingress controller. And other things related to this project is actually one of our intern projects. And our intern is from Berkeley, and he's Max. Unfortunately, he cannot be here today, so I'll be doing the presentation. I've only really just a few slides, so the rest of the presentation is really heavy in doing a demo, and we'll actually show off the Ingress controller that we have. So what the hell is Ingress controller, right? So if you are using Kubernetes in your projects, you will have, like, on the right-hand side, you can see that you have set up a lot of different services, and then each services, you have multiple pods actually handling each of your microservices that you have, right? And so the Ingress controller is there to actually interact the Kubernetes APIs and get those informations for the proxy server to expose your service to the outside world. And so it's a lot about doing the routing in the correct way for exposing your service to your actual user. Because if you just deploy it in the service inside the Kubernetes, all those services are only visible within the Kubernetes cluster by that. So this is not a new concept. Almost every proxy software that we know of has a provided ingress controller. So if you're deploying services on Kubernetes, you can use them to actually do that. So there's Nginx, HA proxy, and actually the Kubernetes project page has a list of all the proxy that can act as an ingress controller for that. So we want to build one for ATS because we have a huge investment in this open source projects, and we want to use it to actually expose our services to the outside user. So the one that we build, this is how we actually works. So of course, inside the particular pod that is hosting the ATS, we actually have built the ingress controller, which is in Go language. And then so what the ingress controller does is actually interact with all the objects that is exposed through the Kubernetes. So your ingress object, S plus D means service and deployment, and the config maps. So these are different default objects that we can actually show off in just a minute. And so Ingress controller is going to turn that and make sure that we are actually updating the Apache traffic service correctly for that. We have a plugin that actually reads some of the changes in terms of what the routing is. And so the routing decision is actually going to be handled through the plugin, and the plugin get the information from the Redis server for that. All right, so it's time for a demo. Let me see how to do this. Wait, hello? All right. Is it viewable? It's viewable, or I should make it even bigger? Huh? Oh, all right. So it's readable. All right, so so this is our repository that we want to open source later on, but it contains an example application. So we build like two Node.js applications. So each one is serving a slightly different HTML page, and so this is another one. And so they also contain the Docker file so that we can Dockerize the Node.js applications, and you can get them deployed. So the way of doing a deployment is pretty simple. So we are creating two namespaces. One is called the traffic server test2. One is called the traffic server test3. And so each of the namespace, we will have two services. The name is pretty much the same. So apps VC1, apps VC2. And these are all under the traffic server test2 namespace. For that, and then we have exactly the same service in traffic server test3 namespace as well. And so other things we have is we set it to have two replica. So altogether we have two namespace. Each namespace will have two service, each service will have 2 pods up and running. So altogether, there will be I'll be running like 8 applications, 8 copies of my applications to that. So how do I play with it? One thing that is super easy to do is you can just install Docker on your Mac, and they actually, not too long ago, they started allowing you to install like Kubernetes in the consumer versions of the Docker. And so once you install it, you can turn on the Kubernetes, and I have Kubernetes almost the latest version now. I think it's 1.15 actually running on my Mac. So I'm not needing any like existing cluster to even test my stuff here. So, oops. And once I have those applications up and running, I start them all off. And so this is actually how it looks like. And so I'm going to see that I have in one of my namespace, I have the 4 pods that is up and running. As I said, 2 of them belong to one service, 2 of them belong to another one. I have another namespace that is having exactly the same setup. So now I have 4 containers up and running, right? So now let's go back to how we are going to define our traffic ingress controller. So in the world of the Kubernetes, in order to expose your applications to the outside world, you need to define the ingress object. So here is the definition of the ingress objects. So when you define the ingress object, you can say that, oh, okay, I want this host, this domain, and for this particular path to go to a particular service underneath the specific namespace. So basically, I'm saying that I have test.media.com, I have /app1, I have /app2, and within this namespace of the traffic server 2, traffic server -test-2, I will route this to the 2 service underneath that particular namespace. And I can have multiple domain that I have up and running. And so this is another one that is with the app1 and going to one of the service that we have set up as well. So once you have the ingress defined, the next thing is you can have the container informations about the pod that is containing the traffic server. So this is actually, we'll create this in its own namespace, which I call it traffic server -test for that. And so we build a particular Docker image that is out of CentOS 7 for now. And so it contains the ingress controller we talk about, and ATS, as well as the Redis. And so we start all them up, and then so now we can actually take a look at how it actually works, right? So
are all these config files read by the Kubernetes, or some of them read by
all these YAML are read by Kubernetes, and it just start off the different containers and pods and things like that. So nothing related to ATS at this point yet, but we'll go into how actually ATS works with it. So we have nothing right now for the namespace for the ATS, but now that we have the YAML file that we want, we can actually just actually look into applying that. So I have the deployment of the ATS that I can put it out. And when the ATS actually start up in that particular namespace, the ingress controller will get to work and then pick up all the ingress object that I've created and put it to work. So besides having the object, I also already have like the ingress created for the different namespace that I just mentioned. Just show this a little bit. Yeah, so as I said, the first ingress I created is under the namespace of the traffic server /-2, and it is like doing some routing for this two particular domain, and the other one is doing a slightly different type of routing for one of the other domains that we have, right? So now let's actually get to work and try to apply the deployment. Okay, so it's creating the things, and so now I can start actually seeing the stuff up and running. Okay, so it's up and running. I can actually log into one of the servers to actually look at some more particular informations. So I'm printing some information out so that we know there's some different services up and running, and it is doing some routing to the correct part for that. So, I'm in my deployment. One of the things about my deployment on the traffic server is that we are exposing it as a node pod, meaning that this is a kind of like a dummy default for the Kubernetes, meaning that I can route all the traffics that is for a particular pod on my cluster to all the nodes that I have. So basically, I'm exposing these applications to pod 30,000 for the that will be routing to the pod 80 of the particular service that we have for that. So you can see now, once I have all the things set up, I can go to the just curl this particular things, and then the Node.js will start serving the pages for me. It's kind of running a little bit slow because I have way too many containers in my Mac for that. But you can see we are actually routing that particular domain to the destination, which is a particular pod that we have for that. And so it is serving the app1. We are actually going to /app1 for the particular domain that we just saw, the test.media.com. So now if I keep running it, because I have two pods for this particular surface that are exposed through this path. So you can actually see that if I keep running this a little bit, my routing will be keep going to different IP address of the pod that has. So I have two pods, so I have two internal IP address that I'm routing to, and I'm just doing a random routing, not a round robin, it's just a random routing at this point to the things. So let's say if I am unhappy and I want to actually change the replica so that it is not having to, I can like just make changes through the Kubernetes API, or actually there's UI, and I'm just using a command line version for it, but you can actually just make changes here. Okay, I just changed the surface that we are going to from having two pod to one pod, and the controller will pick up the changes and right away be changing it so that now I'm only going to go against one pod. So if I keep going, curling the same surface that I have, and you'll see that now it's all just going to one IP address, which is the 10.1.0.121 for that. So that's the job of the Ingress controller, is to say that it would be knowing like what's the situation happening within the cluster. I have a new services up, or my service go from like 10 IP address to 100 IP address, then it's the job of the controller to actually feed those informations to the proxy server. And so the proxy server will do the routing correctly as early as possible for that. So that's the demo. Yeah. I probably can demo, and other things is like you don't just change the routing informations at all. There's, in Kubernetes, they allow you to actually also change your configurations. So in ATS, let's say you have a timeout and your outgoing timeout is, say, 5 seconds. You can actually ship some configurations through Kubernetes and instruct the ATS to actually update itself to change the timeout to a different value. So this is the idea about the config map, as we were talking about how the controller feed off of the information from Kubernetes, not just for the ingress object, but also the service, the deployment, as well as the config maps, in order to like sense the informations to the ATS for that to get itself updated. So that's the ingress controller that I just demoed. And so there's a lot of things we didn't do in this intern project. So we actually need a CI/CD process now if we are seriously in actually making this projects to be open source. The CI/CD project will need to say, right now we are using 718 in the ATS that is inside the container. We need to add some tests. The way that we build the Docker image is not really secure. We need to follow some security best practice in order to build the container in the right way. And then we need to publish the CI/CD process. We need to publish the Docker image to a public repo. And so other people can actually start using it. We need more control for the routing. So you see this is a really bare bone routing. So I get a domain, I get an incoming request with a domain and a path, and then I send it to a particular pod. We need more load balancing options. We need to support like regex related matchings of the path and rewrite it to the right destination if needed. Sometimes we need redirect. Sometimes we need custom response. In the Nginx world, they actually allows you to actually even ship snippet of code. So, for example, you can actually have a Lua code in Nginx, and you define that piece of Lua snippet in Kubernetes YAML. And so when you upload this to the Kubernetes, the ingress controller will download it and then be able to update the Nginx directly, dynamically, and apply that particular snippets on your particular request too. They have other options of integrations with some WAF options, mod securities in the Nginx world, which I also want to copy over to that. Other things we want to do is more control for ATS, right? So you deploy a service, you want to make it secure, so you need to have TLS certificate and things like that. Kubernetes support that. So you can actually get a particular TLS certificate, send it over to some a custom object called a secret inside the Kubernetes. So now the ingress controller is also responsible to downloading that those particular certificate onto the container containing the ATS and refresh the servers with the certificate. And so all these other options about making changes to the ATS as a server, like your logging options, more fields you want to log on, or your caching options, whether you want to turn on or turn off cachings or different things, you can also use Kubernetes to send your information so that a whole fleet of ATS machines will actually obey what you want to make changes for that. And so there's a lot of standard monitoring integrations with other software like Prometheus and things. So we also want to make sure that whatever we are doing, coming up with an ingress controller can actually in the futures to have the integrations and send the particular metric systems to Prometheus. We should have application logging and ingress controller logging so that all those informations can also be like sent over to a central Kubernetes monitoring systems to actually let the user see how the software is actually handling things. So that's pretty much it. So there's a few things I want to discuss, like whether it is a good choice or not when we are building the ingress controller. One thing is like, because the routing decisions is completely controlled by the Kubernetes, so we have no use of the remap.config. So in the architecture, as you can see, when we have a request coming into ATS, we have actually a Lua plugin to actually consult where the decision should go through talking to the Redis servers. And the Redis servers keep getting update from the Ingress controller about the information for that. So I'm not sure if this is the right approach at this point too on that, yes.
So the Kubernetes isn't looking at the HTTP request at all, right? It's just
no,
a
it's
TCP
not looking
connection.
at the incoming.
It goes into traffic server, and then your plugin looks at it and makes the decision.
Right.
Okay.
Yeah.
So I'm curious why or how this is a better choice than using some sort of layer 4 load balancer like IPVS or something as Ingress. I mean, why do you need a layer 7 Ingress controller if you're again relying on Kubernetes to do the routing for you, most of the routing anyway?
Right.
What's the advantage of having a layer 7 ATS sitting there?
Right. Some of the advanced option I just talked about, right? So if you want to redirect, if you want a customs response, and those are like layer 7 like functionalities. So you can actually configure. In the Nginx world, they have all this option to allow you to configure it so that your application doesn't need to take care of that. They just need to serve whatever they're instructed to serve, while the proxy server will be responsible for piercing like a website together with all these different services together underneath it.
Of all the things you wanted to list, how many of those require changes in the ATS core? Or are they all changes in your code?
Yeah, actually, all these are changes within the Ingress controller. So
Okay,
that's
so
really like not too much work we are looking at. So you can look at it as like an exercise of how to actually control the ATS through a standard tool like the Kubernetes.
So the control plane between the Ingress controller and this pod ATSs, that's done entirely by Kubernetes, health checks and stuff. What's the control plane between the Ingress controller ATS and the rest of the pod ATSs? Is that entirely in Kubernetes? Like,
yeah, so entirely is for Kubernetes to handle that. So when we build the Ingress controller, this is actually in the Go language. And what Kubernetes does is they publish a Go library for people to use. So this is pretty much, of course, they have APIs you can talk to, but they don't recommend you to talk to the API directly. They recommend you to go through the Go client library. And so with the Go client library, you subscribe to certain changes in objects, right? So in this particular cases, we are subscribing to changes to Ingress, services, and config map objects. And so based on those changes, and you're operating your cluster, then the controller will just wake up and analyze those changes and then turn it into information that is going to make changes to your configuration to the ATS or make changes to the Redis servers about what the routing situation looks like now within the cluster for that. Yeah.
So if I understand the diagram, there's only one ATS and multiple pods for serving the application. Is that right?
One ATS pod. In this particular example, yes. Yeah.
Right. So one ATS and multiple service pods. Is that right?
When you say multiple service, you mean the pod for the ATS, right?
Well, I'm not really sure.
Oh, you mean the surface, the backend service, right?
So the
yeah,
actual
So we have many different services behind the scenes that the ATS is in front of, yes.
Right. So, and maybe this is another reason to work at layer 7 instead of 4, because, for example, you could terminate TLS on on one single ATS instance, and then have all the
that's true.
applications behind.
Yeah, cool. All right. So that's one thing that we actually don't have remap.config anymore within this particular deployment. Not that we don't have it anymore. We are not looking at it. So the plugin actually take over the jobs of doing the routing for that. So the second thing that I'm not too sure that this is a good idea is that the routing decisions always goes through a Redis query. So we'll send a Redis query to say, okay, for this particular combination of domain and path, do you have do you have a record, and which service I should go to, and underneath that service, how many pods is up and running, and so what kind of like load balancing option you have, and then for now we only have random. So out of those all those pods that is for that particular service, we just pick one and let it go with that. And so that's another decision that I'm a little bit hesitant to say that this is like a final good thing. So it's more like at the beginning, this is a really good choice for a intern projects that we can free ourselves from being too mindful on all the other synchronizations things we have to take care of. So the last thing we want to discuss is options to open source the projects. So I talked a little bit with Brian on this. So this is our internal repo, and I put all the code and how to build a Docker image and the documentation of how to actually run the exact example that we have here. So one of the things is we can put all this thing completely into one directory under the source repository, or the other option is to actually create a separate like repo in Git to just represent this. So I'm not sure if there's any particular preference here. Yeah. Anyone? Separate repo? Oh. You can. Right. Yeah. Yeah, I think this belongs to a separate repo. Yeah. Okay. So I'll work with you offline to create one, and then we can go from there onward to see like setting up the CI/CD and like continuously feeding the latest to the to create a Docker image in the public repository for that. Yeah. All right. Cool. Anything else?